Well, what do we do with all the energy that we've generated once it's been generated? This is the biggest problem. Is it's all very well having massive energy generation, but the energy has to go somewhere. If we're generating excess energy, where does that energy all go and how do we store it? This is the biggest problem because generally the way it goes with electrical energy storage is that it degrades over time. I mean, it's a sort of, I think it's fair to say it's a fairly universally known fact that if you say have a lithium ion battery and yeah, you leave it, even like say if you had a phone or something which you left in a drawer for years or something like that, even if you left it charged up when you put it in the drawer, say 3 years later you come back and you find it at the bottom of an old drawer, the chances are when you turn it, if you try to turn it on, it won't turn on because the energy's gone. Or if it does, the battery won't be 100%. It'll degraded. The energy storage will have degraded over time, and that's one of the biggest challenges is how to keep storage, how to develop, say, batteries that don't lose their charge over a period of time. That's probably one of the biggest challenges of batteries because it's so inefficient. The fact that you think about like you can put all this energy, you can make a battery store energy, but from the minute you unplug it from the storage, from the generator, it's starting to very very slowly lose charge. Um, yeah, so there's a lot of development being done in battery tech at the moment, and particularly by my favorite Tesla. Oh, there we go. I've left in the notes from before, so I'm just going to type here, and you guys can make your own notes on here. Yes, in fact, it'd be better if I just copied and pasted this, wouldn't it? So luckily with this, it's a very, very short section. So this first method here, kinetic pumped storage, this is kind of what I was talking about with the Three Gorges Dam. In fact, it basically kind of is the Three Gorges Dam. So sometimes what countries will do is instead of having a river, you might have artificially built reservoirs. Now, one reservoir will be slightly higher than the other one. And what they'll do is they'll literally see them as being like water batteries. So the water on the higher reservoir is the potential energy that's stored. And I mean, yeah, it just uses gravity to pull it down to the lower reservoir. So if, like I was saying before about, energy spikes happening, or you need suddenly a massive injection of energy into the grid, all they need to do is just open the sluice gate, let the water through, and that will generate a massive amount of energy that will be fed into the grid almost instantaneously. Then the theory with these kinetic pumped storage systems is that once that energy is no longer needed, so say maybe in the middle of the night when energy consumption is very, very low, what they'll do is any excess energy left in the grid, they will then use that to pump that water back up into the upper reservoir again. So the idea is it's only using excess energy that's not needed to pump back up into the upper reservoir. Which is kind of cool, but it's also, you've got to think of it this way, like these are very, very quick to discharge and very slow to recharge. They are like a supercapacitor in a way. They can store a huge amount of charge and it'll like bomb the grid with loads of energy, but it's like one shot wonder. Once it's gone, it's gone, and then it will take a long time to refill the reservoir again. So, and use a lot of energy. I mean, arguably it'll use as much energy to recharge the reservoir as it did to discharge it. So yeah, it's a sort of you're I guess with these you're only ever going to be energy neutral with them. So yeah, batteries. Oh, there we go. Yes, this reminds me actually. I'm glad I saw this. I might leave these notes here actually. With this exam, for some reason, they want you to know that rechargeable batteries deliver only 1.2 volts, whereas single-use ones like Duracells on the top right there store 1.5 volts, or they give out 1.5 volts. So the reason for that is because the chemical makeup of the batteries is different, and that affects the voltage output from them. So yeah, lithium ion commonly used in laptops, 1.2 volts. So to get a higher voltage, they basically have to link batteries together in series. And that's why if you look at a Tesla battery pack, let's just get one. It literally just looks like a ton of batteries just all kind of soldered together. Here's a good image of it. They literally just have loads of batteries There we go. Just a ton of batteries inside this container, which goes right in the bottom of the car, and they're all linked up in series. And doing that like generates a nice big voltage, which will then drive the motors. Yeah. So yes, single use. These are commonly made from like you get like alkaline batteries or lead acid, zinc cadmium, or you get these ones PP3, which are like the sort of the little rectangular ones with the two little stubs on the top. Hopefully, you guys are not very familiar with these because ideally you don't have to use them too much because most electrical products come as rechargeable now, which is good. But cheaper things often don't, and you have to get like a single-use battery. So wherever possible, designers need to design to not use these. Yeah, so there have been some questions in the exam before about like working out what the cost difference would be between changing a set of single-use batteries over recharging a number of times a set of rechargeables, and it's like comparing the cost between them. So yeah. Positives of single use are that they obviously have higher voltage, but positive rechargeables, they can be used multiple times before they need changing. The single use ones are terrible for the environment. In fact, terrible, terrible, terrible. I'm almost surprised that some countries haven't banned the sale of disposable batteries, given that a lot of countries have now banned single-use plastic bottles. You think they'd do the same with single-use batteries as well, because the chemicals in them, like lead acid, being leaked into the ground, like that is not good news. And the downside of rechargeables is the voltage output's quite low, and they've got a limited number of recharge cycles that certainly basic ones like this have. Okay, that's it. Thank you very much.